To apply the simple linear regression model, one should keep in mind that in the simple linear regression model, we have one dependent variable and the other second variable is an independent variable. So if you look at these three variables, revise, exam, and anxiety. So the exam performance can be dependent variable here, whereas the revise and the anxiety, these are the variables which can be called as independent variables, because we have directly no control over the exam performance. So that's why the exam is your independent variable. Sorry, exam is your dependent variable, whereas anxiety is your independent variable, and the revise time is your, the time to revise the course is your independent variables. So dependent variable is random, whereas the independent variables are fixed. These are non-random values. And one of the main assumption of the regression model is your dependent variable should follow normal distribution. So first we check the normality of our main dependent variable, which is exam. So to test the normality, I just press the analyze and then non-parametric. And then we have here one sample case test. You just select here the exam performance. We are keeping only one variable exam performance here, leaving the others. So the p-value is combined p-value is 0.048. So I consider it as close to 0.05. It's rounded to two decimal places. It will be 0.05. So we assume that your exam performance is following normal distribution. And now to fit the model for the simple linear regression model, you just go to the analyze and then regression and then linear regression. So here, normally in the normal routine for the situation, all the variables are lying here. So here you select your dependent variable, which is exam performance, and the next either one of either variable you can have for independent variable. So let us select this exam anxiety here as our independent variable, and now in the statistics, pressing the statistics button, so you will just click on the Durbin-Watson estimates and the model fit. These two options are selected by default, whereas the Durbin-Watson statistic is selected by ourselves. So we just continue over this, and now there is no any other option that we need to select. You just press the OK button, and then we'll have such output that basically the year table is indicating which of the variable is dependent and which is independent variable. The next variable is showing the model summary, and the next is the analysis variance p-value, and the next table is showing the parameter estimation of the model. So these are important uh, three tables for the simple linear regression model. And now I take you to another document where I have pasted all these tables on a Word document with the details and interpretations. So this is a simple linear regression. So first, the normality test has been performed here. So all three variables have been taken here. So it is assumed as normal, and whereas these two independent variables are non-normal, and these are independent variables, I have taken only one variable for the analysis, which is exam anxiety, as an independent variable. So here we have a brief detail about the dependent variable. It has other names as well, such as dependent variable or study variable or response variable. So here exam performance is your dependent variable. These should dependent variable should follow normal distribution and it is random, whereas your independent variables, it has other names as explanatory variables, predictor or regressor. So here we have two independent variables, but for the regression model fitting, I'll be using only one. Why? Because it is simple linear regression model where only one predictor is used. And now the reason is explained here why it is normal or non-normal. So details are lying here. And now let me explain the first. After the first table, we have a second table. In the second table, we have a value r and r square, then adjusted r square, and then standard error of the estimate, then Durbin-Watson statistics. So here the details of all these important statistics are given. That is R. What is R? R is your simple correlation measure between the two variables or dependent and independent variables, the exam performance and exam anxiety. The correlation between these two variables is 0.4 for 1. It will not be showing any negative or the positive sign in this output. And the next value is r square. R square is 0.194. We interpret this value after multiplying it to 100, then we get the result in percentages. So we have 19.4%. So in this model, we can say that 19.4% of the variation in the exam performance is explained by the exam anxiety. So I won't say that this model is a very good model, because we are hardly contributing from our independent variable only 20% variation, whereas 80% of the variation still we are unable to explain in the exam performance. So anyhow, we cannot consider this model as a good model, but let me explain it further, what the parameter and the other measures are here. And now next to the R square, we have adjusted R square, which is 0.186. That is less than the R square. When there is such tendency, it means in this model, if some additional terms are used in the model, such as square terms or the uh, cube terms of the independent variable, there will not be any improvement in our predictions. So that is the use of the adjusted R square. And next to it is Durbin-Watson. Durbin-Watson statistic is actually identifying whether our model contains some autocorrelation issue or not. So this value should be this 2.065. This value should be 1.5 to 2.5 in between. Here it is written that this value should be in between 1.5 to 2.5. In case it is lying in this interval, our model is safe from autocorrelation. But in case there is autocorrelation, there are other methods to get rid of such problem. And now the next table is NOVA table. Here only one value is of our interest, and that is the p-value, which is 0.000 here. So it indicates that our model is significant model. And if your model is significant, then it is useful to discuss the other things of the parameter of the model, uh, regression model. And the next two is the coefficients table, where we have estimates of our regression parameters. And now let me explain the population simple regression model here. So this is the population simple regression model, yi equals alpha plus beta xi plus epsilon I. Here yi is indicating or representing the dependent variable that should be normally distributed, and alpha is the intercept. It is a parameter of the regression model. And then another parameter is beta, which is the slope of the line or the regression coefficient of the model. So here we have two parameters. And what is beta? Beta is actually the change in y uh, after every single unit increment in your independent variable. It has been explained here in the document. You can just go through it. And the x is your independent variable, and in our case, our independent variable is the exam anxiety. And this is the error term, ei. This should follow normal distribution, and it is distributed normally with zero mean and variance at sigma square. And now copying again this table here. So here we go with, so the first of the coefficient here, this is 106.071, is your estimate of your alpha, and the minus 0.666 is your estimate of the beta. So the estimated regression line or the regression model is written over here. So if you plug in all these estimated value on the place of alpha hat and beta hat, we have our estimated model as yi equals 106.07 minus 0.666 into the anxiety. So anxiety is your independent variable. So to use this model, we'll plug in the value of the anxiety, and we'll be able to estimate the exam performance of such candidate. And now how to use this model here. So here we have, I've taken one of the uh, data observation from the given data, and that is a candidate with code number 70. His exam performance is 60, and he has anxiety level 63.73. And now we use the model for the prediction or estimating the marks. So here I have seen this is the 106.071 is the same model I have written here. And now plug in the value of anxiety here, which is 63.73. And after calculating and making the important calculations, the estimation is 63.63. It means that if a candidate has anxiety level 63.73, his expected exam performance would be 63.63. And now we can have another measure, that is a residual. Residual is the value which remain unestimated by using this model. And how we can calculate the residual, that is a formula once you have the difference between the actual value and the estimated value. Since the actual value was 60 and the estimated value is 63.63, so if you take the difference, this is minus 3.63. So our model is overestimating, that is indicated from this estimate, which is minus, and in case positive, it means the overestimation is there. And now another property of the regression model is if entire data are used here in the model and all the residuals are calculated, and if you take the sum of all these residuals, that should sum to 0. So these are something related to the regression output, and that's how we can fit a simple linear regression model to any data. And now for your own practice, I would suggest that you take the same data from this data sheet, and you just replace this anxiety with the revise, and evaluate the regression model once again and see what is the output and how you can interpret that regression model. So that's all for the simple linear regression model. In the next video, we are expected to see the fit of multiple linear regression models.